All right, class, welcome back. Again, this whole lesson is about triangle congruency and the shortcuts that we can use to prove it. So when you're doing proofs, your best friends are corresponding parts of congruent triangles are congruent, C, P, C, T, C. All that basically says that if the two triangles are equal, then everything inside the triangle is equal. Now, before you can get to that, you need to know the shortcuts: SSS, SAS, ASA, and AAS. Those are easy to know because the A stands for angle, S stands for side. So SSS is side, side, side. SAS is side, angle, side. And ASA, which is the construction we're going to do right now, is angle, side, angle. And the last one I did, the SAS, I was kind of proud of myself because it actually came out perfectly. Except for me trying to figure out how to rotate it. But that's fine. All right, so let's do this one. Again, the same procedure. Let's draw a triangle. And again, you can draw any triangle you want. It doesn't matter. So I'll just draw a simple one. Now, for those that are thinking about it, if you're doing ASA, then that means now you're not copying one angle, you're copying two angles, and you're copying one side. Just for those that are curious about it. So we're going to call this C. We're going to call this B. And we're going to call this A. There we go. Alright, so this is triangle ABC, CBA. However you want to do it, just make sure you put the triangle symbol in front of the three vertices, and don't forget the vertices are the points of the triangle. Alright, so like anything else, when you're constructing, you need a foundation, and the foundation here in this case is the line. So we just put it here. Oh, before we do that, let's make sure this is good. Yeah, I want to be able to use this later. Alright, cool. Alright, so let's just draw a line. Okay, and then they want to call this point L. Alright, and then we just got to copy which segment? CB. They want us to copy CB. Oh, that's perfect, which is this one. Alright, good. So CB is basically the actual side that's in between the two angles, or what they call the included side. When they say included, that means in between. If they say included angle, like in SAS, that means in between. So this is a side that is going to be in between these two angles I'm copying. So I know that's how long CB is. So I go here, like always, do the same thing. Let's make our mark. So that point right there is CB, which is going to be here. It's going to be probably LK. Yeah, LK. There we go. All right. So we already got our first corresponding part, which is the side. So I'm just going to put a big S here and an S here. So we already got two sides that are congruent. So now what we got to do is copy the angles. So my hunch is it's going to be angle C and angle B, because those are the two angles that's where this side is in between. So let's go with C first. Yeah, which is what they want us to do first. Okay, good. So let's just copy C. So when you're copying any angle, you're basically making an arc. Let's make sure I do it this way. Okay, good. Oh, there we go again. There we go. Okay, that's why. So here's the first arc. Good. Alright, so Since I know I'm going to copy B, I might as well just do this all at the same time. Why not? That's done. And then I'm going to go where K is at and do the same thing. These are acute angles too, so this is more than enough. Alright, so I got everything done. So let's measure. So to measure C, you know angle C goes from here to here. So that's what I'm measuring. And then angle B goes from here to here. Once you make the arcs and they both have the same radius, then it's easy to copy the angles, because the angle is just this distance. This is how far the angle rotates. And the only way you can mimic a rotation is by basically making an arc which is really part of a circle. So now I showed you where the actual measurements are for both angles. Let me just erase that. And let's just measure it. I'll keep it orange too, just so you can see what's going on. Alright, so this one goes here. Now obviously this is way too big. Alright, that looks good. So let's make sure. Yeah, that's perfect. Alright, so let's make our mark just to let us know that we're in the right spot. Then we just go here. Notice I'm taking my time with this, so like I said, it's easier on paper. If I was doing this on paper, this will be done in pretty much less than 5 minutes. Alright, so that's done. That's how big that angle is, which, yeah, it looks about right. So now, let's just measure this angle. Now, what they tell you to do, though, is that once you measure the angle, they want you to draw this line. So let's just draw it. They just want you to draw any random line. What's going to happen is that once you get this angle, and you draw both lines where they both meet or they both intersect, that's where the other point's going to be at. Yeah, that looks good, I think. Let's check. Again, I'm just doing this because I want to make it come out as perfect as possible. That's 18. What's this? That's like 20, so then no, that's wrong. That needs to be a little bit more up. That's where I had it, so. Alright, that looks good. Alright, so let's see if that works. Yeah, that's better. Alright, so I got that one. So let's get this out of the way. Now let's measure this angle. So I know it's here. And again, what I just did, you can do too. Take the protractor, measure the angle. You know you got to copy them, so you can always measure them. No one tells you can't do that. Yeah, that mark is perfect. So now I go here. I just mark it there. And I'm good with that. So now this angle is the same as this angle. And don't forget, the angle is the rotation in between the two sides, the two rays, the two lines, whatever it is. Alright, so let's see. Let me try this to see if that works. Alright. Yeah, this triangle looks exactly like that. And that point's supposed to be J. So before I do that, again, I want this to come out as perfect as possible. So let's measure. That is exactly 30. Hoping this is 30. Nope. It is... Oh, it's off by a degree. It's actually like 29. Alrighty, so let's just do this over. You know, I'm just going to leave it there. Just, okay. Yeah, let's try that. All right. Yeah, let's try to see what that is. And again, I mean, I'm just being picky, but the reality is both these triangles look exactly the same. Yeah, that looks about right. Let's see what this is. Yeah, that looks good now. All right, so then just to recap, so we got here an angle. This is a little trick I'm going to show you guys in class, but this is how I know which if these triangles are congruent. So I got ASA, angle, side, angle. I do the same thing here. Angle, side, angle. Now what am I doing here? Basically, I'm comparing the corresponding parts of the triangle. So these two angles are congruent. These two sides are congruent. These two angles are congruent. So by the ASA congruence theorem, these triangles got to be exactly the same, and they are. And I'll prove it to you. Let me just finish this. This point should be J. Right here, this point's J. Oh, that would help. There we go. That point's J right there. All right, so let's put this one on top of that one. Let's see if it is the same. I'm hoping, but you know, I'm probably going to be off. Yeah, I'm off just by a little bit. That's fine. Yeah, this line should have been more this way, but you get the idea. And again, on paper, it should come out right, but for me, it didn't. That's fine. But you can see that these triangles are basically the same. And again, actually, I had it right. It shouldn't have been measuring so much. So now you know by the angle side angle theorem, both these triangles are exactly the same. So if you're doing a proof and you're trying to prove, let's say, side AB is congruent to JK, once you've proven that the two triangles are congruent by the ASA theorem, then you can just use corresponding parts of congruent triangles are congruent to just prove that the other side is congruent to this side. Just because that once we prove the triangles are congruent, then everything of the triangles are congruent. Alright, thanks for watching. See you in the next video.